Swayam Prabha. Digital India. Educated India.
the other things, other process parameters are equal or constant. So, to have the higher width to height ratio, you can decrease the PFR value or you can increase the TS value. So, why this is happening? The reason is that the lesser volume of powder is available per unit clad pass, giving rise to a flatter clad pass profiles. So, when we are having the decreasing PFR value, when low amount of powder we are applying, then we are getting flatter clad pass profiles. So, this W by H ratio is dependent upon higher values of width. So, when low values of PFRs are there, when low volume of powder is available, then certainly we are getting a flatter clad profiles, and it is also related to increasing the translation speed. So, low interaction time is also maintained, that is why we are getting flatter beads as well. Now, there is another parameter that we will also to be taken into consideration, that is the dilution. So, dilution in case of laser cladding is defined as the proportion of the parent material or the substrate in the clad layer. So, we have to find out how much is the dilution of the parent material inside the clad material. In laser cladding, this is considered is not desired. So, there should not be more amount of dilution of the substrate material inside the clad material. At the interface only there has to be the dilution of the substrate material inside the clad material. So, the dilution of the clad layer increases with increasing TS and decreasing PFR. So, here we have taken translation speed on x axis and the dilution on the y axis, it is in percentage. Again we varied the PFR in 3 levels, 10.8 gram per minute, 16 gram per minute and 20.4 gram per minute. Now, you can notice here the dilution percentage is increasing with TS, that is a scan speed, but it is decreasing with increase in the PFR. So, if we are putting up more powder feed rate, then the dilution is getting decreased. So, higher TS for a given PFR or lower PFR for the same TS gives high degree of dilution. So, if you are working at very high TS value, high translation speed value, and if you are working with lower PFR, so here you can see this is the lower PFR value, then you are having higher degree of dilution. So, the dilution is much more higher in this case. So, this is the result of lesser volume of powder available per unit length of the clad pass when either PFR is decreased or the TS is increased. So, this higher degree of dilution is again related to the volume that you are applying for the cladding material. So, when there is lower value that you are applying for the deposition, then there would be more dilution is getting occurred during the deposition. So, that is the conclusion of this particular graph. In addition to the dilution and the clad profile, we can also study the surface hardness. The clad passes produced at higher PFRs generally registered a higher hardness than those clad at lower PFRs. So, for higher PFRs, so if you notice higher PFRs are this 20.4 gram per minute. When we plot TS along x axis and hardness along y axis, so for higher PFR values the hardness are more. Interestingly, at a PFR there exists a peak in the hardness which occurs over ranges of the TS of the laser beam. So, if you just notice over here, there is a peak is occurring in the hardness and then it is getting reduced. The hardness is getting increased, it achieves its peak and it attains its peak and then comes down. So, this is achieved at a range of about 350 to 450 per minute for the TS, for the translation speed, and for the higher value of PFR, that is about 20.4. So, for 20.4 and in between 350 to 400, there is a maximum hardness was achieved. Now, let us look at the microstructures which are generated during this laser cladding process. On your screen, you can see the microstructure at high hardness and low hardness. So, this A belongs to high hardness. So, this is the microstructure related to high hardness and this is related to low hardness. So, what we noticed here, the clad layer of the highest hardness has a structure in which fine and angular hard particles, and these are dominating the feature of hard phases. So, if you just look at this microstructure, you will find that there are angular hard particles. So, these are all the angular hard particles that you can notice. They are fine, but they are angular, and these are the hard particles which are increasing the hardness. For the specimens with lower hardness, so various amounts of coarse leaf like phases were observed. So, these are the leaf like phases were noticed during the optical micrograph study for the lower hardness cladded material. Now, let us see what are the various applications of laser cladding. So, here you can see there is a cylinder head and there is a crack which is occurred at the cylinder head, and by applying the laser, by carrying out the laser cladding operation. So, this is the laser cladding which is getting done. So, this surface is cladded over here, and after that it was finished. This surface was finished and is ready to use for further applications. So, the repaired cylinder head after the cladding, that you can notice over here. Finishing operation is of course essential to make it ready for final application and to get its original dimensions. It was observed that the remanufacturing could cut environmental impacts for the whole life cycle by 63.8%. So, approximately 60% of the environmental impact for going for a new product can be saved. So, this simple laser cladding has saved the entire cylinder head, and which have saved lot of energy, lot of resources and money as well. Two more examples are there in front of you. So, here we are having a turbine blade tip. So, this is a turbine blade tip which is laser cladded, and this is a rail. This is the rail surface, and this rail surface has been cladded. So, this is a cladded surface. Fine. So, with this I would like to summarize today's class. So, we have seen laser cladding, its principle of operation, its difference between its difference the difference between LSA, that is a laser surface alloying, and LC, that is a laser cladding. And at last we have seen a case study with certain applications. So, with this I would like to conclude this lecture, the lecture 4 of week 5. In addition to this, I also conclude this week as well on laser based surface treatment. In the next week, we will study the additive manufacturing techniques where lasers are used. Till then, goodbye. Thank you.